Okay, so I'm going to be doing the dosage calc for, I believe it is for pediatrics, in 4283 acute clinical thing. So you just go in there and find it. I'll do number 1. It says the safe dose for erythromycin is 20 milligrams per kilogram per day, i.e. 24 hours, in 4 equal doses. So off the back, what I usually do is I just do 24 divided by 4 equals 6. So you know this right here is going to be 6 times a day. I apologize, not 6 times a day. Every 6 hours. You're doing it 4 times a day. So then it says the child is 33 pounds. So we know it's 20 milligrams per kilogram per day. So we're just going to convert that to kilograms right off the bat, so we don't have to do it later. So you just do 33 divided by 2.2. And this is because 33 pounds is equal to 2.2. This is the conversion. 1 pound is 2.2 kilograms. So these are essentially the same. So just get in a habit of converting your pounds to kilograms as soon as you see it. Like that should be one of the first things that you're doing. So we get 15. So then it's asking us, the medication is supplied in 125 milligrams per milliliters. Okay? And this is our safe dose. So let's look at our questions. Our question says, how much is the child weight in kilograms? So we've already calculated that. That is right here. Calculate the safe dose for this child. So the safe dose is 20 milligrams per kilogram per day. So we have 15 kilograms. So 20 milligrams per 1 kilogram. And our child is 15 kilograms. So 15 times 20 is 300. So it's 300 milligrams per day. And you want to give that in 4 equal doses. So you're going to do 300 divided by 4. Is 75. So I'll just write that here. So you're doing 300 milligrams divided by 4 times per day. So you get 75. So you get 75 milligrams per dose. Okay. So the next question is, how many milliliters will be administered for each dose? So that's where you're going to take your supplied. We'll color that in blue. You're going to take your supplied and you're going to go, it's asking how many milliliters per dose, so you're also going to need your safe dose range. So you're going to do, so it's asking, it wants to know amount of milliliters. So if you want to do it like this, so you know what you're looking for, milliliters per dose. And you're going to go start with your milliliters and your supplied. So it's 1 milliliter per 125 milligrams times your safe dose is 75 milligrams per 1 dose. And here you can see that you have your milliliters per dose already calculated. Cross out your comments. So you have 75 milliliters per 125 dose. So you're just going to divide that now. So you have 0.6 milliliters per 1 dose. And there's your answer for that. I believe we're going to color that in yellow. Okay, so we're going to move to number 3 because number 2 is just like number 1. So number 3 will be a little change, not too much. So it says the recommended dosage for oxacillin for a child is, so we're going to put our safe dose, is 50 milligrams per kilogram per day. So what are we doing? Okay, we're going to do just like last time. So per day is, remember, 24 hours. So, and it goes on to say in 4 equal doses. i.e. 6 per Q6 hours. So every 6 hours. Remember we calculated that time last time. So same. So then it goes on to say our child weighs, so we'll put weight, 66 pounds. So just like last time, we're going to do 66 divided by 2.2. Why? Because we have this conversion here. 66 pounds convert to 1 kilogram over 2.2 lbs pounds. That's the same thing, remember? Just repetition will keep it going in your head. So we're gonna do 66 divided by 2.2 is 30. So we have our child weighing 30 kilograms. And remember, we're doing this before we even look at what they're asking us for, because we just want to make sure that all our conversions are matching up. So you don't want your pounds here and kilograms here. We're going to convert to make them the same. So we're converting 2 kilograms. The reason why we don't convert to pounds is because a lot of times in calculations you're using the metric system. So you're most likely always going to convert to kilograms. So now our question says, or is saying this, the medication is applied in, so supplied. 250 milligrams per 5 milliliters, i.e. the change in this question from number 1. That is our change. So just like question 1, it says, what is a child's weight in kilograms? Boom, we got it already. Oops. So let's take that off. We already got our kilograms. Calculate the safe dose for the child. So let's go ahead and do that now. So we have our child weighing 30 kilograms. So just like last time, we're going to do the safe dose for the child. So we're doing 50 milligrams over 1 kilogram. And our child is 30 kilograms. So let's calculate that. So we're going to do 50 times 30. So we have 1,500. So we have 1,500 milligrams, because we cancel all our kilograms, per day. And remember, that's every 6 hours. So that's 4 times a day. So our safe dose per dose is going to be 1,500 divided by 4. So don't get that confused with this Q 6 hours. It's still 4 times a day. Is 375. Oops, I should have put my units here. $375 milligrams per dose. Okay, so you always want to keep up with your units. So we're going to highlight our answers in green for the questions. Oops, highlight, not marked through. Okay. So now our last question. How many milliliters will be administered for each dose? So we have to go back to looking at supplied in 250 milligrams per milliliter. So it is asking us how many milliliters is in each dose. So this is what we're going to end with, milliliters per dose. So let's set it up that way. So we have it supplied in 5 milliliters per 250 milligrams. Then we have here our 375 milligrams per 1 dose. Okay, so after this, we're going to end with here, milliliters per dose. So let's multiply across, divide top and bottom. So we have 5 times 375 is 1875. And then we have 250 times 1. We know that is 250. And let's bring across our units. So we're bringing across our units. So we're going to simplify now. Simplifying meaning the top divided by the bottom. So we have 7.5 milliliters per dose. Okay, so that's your third answer. Okay, so now we're going to move on to number 4. Number 4 is a little different because you have you're starting to include ranges of recommended and safe doses. So let's read the question. The recommended dosage, so we're going to go recommended or safe dose is, here we go, for amoxicillin is 20 to 40 milligrams per kilograms per day in equal doses Q8 hours. So day is, remember, 24 hours. So instead of giving us every 6 hours, it's doing every 8 hours. So we have 24 divided by 8. So we have it 3 times a day. So it's Q8 hours. So that's 3 times a day. Okay. So next it says the medication is applied. So we have our supplied in 50 milligrams per milliliter. Okay, and the child's weight is 72.6 pounds. So automatically, remember, what are we going to do here? Convert. So we have 72.6. We're going to write capital L so we don't confuse that for a 1. 72.6 pounds. And this is our conversion, remember. We're converting to kilograms. 1 kilogram over 2.2 pounds. Or 72.6 divided by 2.2. So we have 33 kilograms. Remember, cross out your commons. So this is also known as 33 kilograms, or converted to 33 kilograms. Boom. So now let's look what our question's asking us. What is child's weight in kilograms? We've already gotten that. Calculate the safe dose range for this child per day. Okay, so let's write this out. Per day, remember, so we have our kilograms, so it's 20 to 40 kilograms per day, milligrams per kilogram per day. So we're going to do this in 2 separate equations. So we have 20 milligrams per 1 kilogram, and our child is 33 kilograms. So that is going to be 20 times 33. So we have 660 milligrams per day. And then we have 40 milligrams per 1 kilogram. Child is 33 kilograms. So that gives us 40 times 33 is 1,320 milligrams per day. So our safe dose range per day is going to be 660 milligrams to 1,320 milligrams per day. Okay? Okay. Next question. Calculate the safe dose range for each 8-hour dose. So basically it's asking us here to calculate the safe dose range. Safe dose range per 8 hours. So when you're looking at this question, you really want to think, all it's asking is calculate the safe dose range per dose, because you're giving it every 8 hours. So that's going to be, every 8 hours is going to be your 1 dose, right? So we calculated up here that every 8 hours means that you're giving it 3 times a day. You're giving it 3 times a day. So essentially, you can really take this number right here and divide it by 3. So you're going to have 660 milligrams divided by 3. You're going to take 1320 milligrams divided by 3. So that's 220 milligrams per dose. And then we have 440 milligrams per dose. So our safe dose range every 8 hours is going to be 220 milligrams to 440 milligrams. Let's erase this. Per 8 hours. I don't know why I keep doing the lines. Okay, so for the last part of this question, it's very detailed, so you really want to pay attention to the wording. So I went ahead and wrote out and underlined some important information you need to take out of this question when reading it, okay? Because due to the amount of words, you may get flustered and be like, okay, what do I need to know? What am I supposed to take from this question? So you're going to say, how many milliliters? Okay, we need to know that it's milliliters, because above you'll see it's milligrams per dose in hours, right? So we need to convert it to milliliters. Will be administered for a single dose, right? Single dose. If the child is receiving the 20 milligrams per kilogram per day dose. So we're going to go in here and look for this information that we've already calculated, because we don't want to recalculate something that we've already calculated. So boom, right above we have information that we can utilize. So the information above is giving us the safe dose range Q8 hours is giving us the safe dose range for per dose, right? And that's what we're looking for here in single dose. Single dose. That is like huge information that you need to actually pay attention to in this question. So you have 220 to 440 milligrams per 8 hours per dose. So you want to utilize this 220 number, because remember 220 is the 20 milligram part of this equation. So you're going to use the 220 milligrams per 8 hours, or per dose basically. That Q8 hours might throw some people off, so just know it as that's how much you're going to give per dose to this patient. So every 8 hours you're going to give 220 milligrams to this patient. So now we need to convert our 220 milligrams per dose to milliliters. So where do we have milliliters at? Our milliliters is here. Let's do it in blue so you can see it a little bit better. Again, underlining blue. So we have our 50 milligrams per milliliter. So we're going to put that down here. So we need to know that we have 50 milligrams per milliliters. This is where we're going to get this milliliters from. So you have you want it to be in milliliters per dose. See how the question doesn't really change? It's the wording that kind of might just throw you off. So you really want to dig for what you are looking for specifically. So you want milliliters per dose. So let's set this up. We have 1 milliliter per 50 milligrams. And if this patient is receiving the 20 milligram dosage of this medication, they'll be receiving 220 milligrams per 1 dose of this medication. So boom, now we've got our answer right here. So we have 220 milliliters per 50 dose. And literally you're just bringing this information straight across. You're multiplying it across and dropping it here. Okay? So now let's simplify. So we're going to divide 220 by 50. So we got 4.4 milliliters per dose. Okay? Okay, so after looking at number 5, it looks like it would be beneficial for me to show that one too. So we're going to look at number 5. So it says a physician orders vancomycin 400 milligrams oral every 6 hours for a child. So this is going to be our order. For a child weighing, so remember weight, 90 pounds. So what are we going to do here? Boom, we're going to convert. So we got 90 divided by 2.2. And this is where we're going to use our rounding rules. So we're going to do 40.91 kilograms. And the vancomycin is supplied, available. So we're just going to change that to supplied. So we can keep our terminology continuing through the entire problems through the paper. It's available or supplied in 250 milligrams per 5 milliliter concentration. The recommended dose, so this is our recommended, is 40 milligrams per kilogram per 24 hours day. Same thing. Divided in 4 equal doses. So 4 equal doses is the same as what? We did this earlier, 6 times a day. I'm sorry, I did the same thing last time. It's every 6 hours. Q6. Boom. What do you see is the same? You're seeing the same as the order, so we don't have to worry about converting anything for the amount of times per day. So let's look at our question, because you already know we've already answered some of these. So we have, what is the child's weight in kilograms? You got that. Boom. Done. How many milligrams per kilogram per 24 hours is the patient receiving? Okay. So here's where it gets a little funky. Okay, we got 400 milligrams Q6 hours. This is how much we have in our order. And this question is asking how many milligrams per kilogram per 24 hours is the patient receiving. So in this order, we have 400 milligrams per 6 hours, okay? So this is also, we want to convert this, so how much is this in 24 hours, right? Because this question is asking how many milligrams per kilogram per 24 hours is the patient receiving. So that's why we're doing the 24 hours here. Sorry if I'm repetitive, because it's repetition is how it gets in your brain, and you'll ask the same question, so it's better just to repeat it and keep it in your brain. So 6 times 4 is 24, right? So basically we need to multiply this by 4. So that's 1,600. So our patient is ordered 1,600 milligrams per day or per 24 hours, right? So now it wants us to take this right here and figure out how much they're receiving per kilogram. So this is what we're going to do. We know how much the patient is in kilograms, i.e. right here. Okay? So now we're going to take this number and divide it by their kilograms. So now we have 1,600 milligrams divided by 40.91 kilograms. Because you want to know how many milligrams per 1 kilogram this patient is receiving. That's why we're doing this. So we're going to use our rounding rules. So we have 39.11 milligrams per 1 kilogram. Okay, and then this is also, we've already completed that, so that's also in 1 day. So we've answered that question. The question again, here we are again using our lines. The question again was asking how many milligrams per kilogram per day is this patient receiving? And we answered that in that question. So next question is asking, is the order safe? So let's go back to our recommended dosage. The recommended dose is 40 milligrams per kilogram per 24 hours. We got this information. Let me write this out. Is it safe? Yes. Because this is basically less than this, so it is safe. If yes, how many milliliters are needed for each dose. So we have our supply right here is 250 milligrams per 5 milliliters. So let's write this out. So it's asking basically for milliliters per dose. Okay. So our order is giving us 400 milligrams per 1 dose. And our conversion is 250 is 5 milliliters over 250 milligrams. And just in case you were wondering, you want milliliters per dose. Because I forgot to add that at the beginning, like we've been doing. So now you're going to multiply across, and you're going to divide top and bottom. So you're left with milliliters on top and dose on bottom. So we're going to do 2,000 divided by 250. So you'll have 8 milliliters per dose. Okay, so now we're going to move on to number 6. Number 6 says a child, also you want to look at that maintenance rate table. That's what you're going to be using for the calculations in 6 and 7. So 6 says a child is to receive IV fluids at maintenance rate. The child weighs 14 pounds, also known as what in kilograms? We're also going to use our rounding rules, so it's going to be 6.36 kilograms. Calculate the fluid. So then you're going to move on to your questions, because that's all it gives you. It just says a child is to receive IV fluids at maintenance rate. The child's weight is 14 pounds. The first question is how much the child weigh in kilograms, which you've already gotten. Then we want to calculate the 24-hour fluid requirements for this patient. So according to the chart, if a patient is between 0 to 10 kilograms, they're to receive 100 milliliters per kilogram. Okay, so just by this, what do you think we're going to do? Set up our chart. So we're going to do 100 milliliters per kilogram, and our child is 6.36 kilograms. So they're going to receive how much? (636 milliliters of fluid per day. Okay, the next question is how many milliliters per hour are needed to deliver the maintenance fluids? So the question is how many milliliters per hour? Okay, so boom, we're going to, don't freak out. Okay, so we have, because I know it's easy to start freaking out if you're like, holy crap, what do I do? Okay, so you have 636 milliliters per 1 day, right? Boom. Think of it like this. You want per hour. So there are 20 and sorry, I do apologize because you have to set up the chart so you can cancel things out. So for one day, how many hours are there? There are 24 hours. Because you want to know milliliters per hour. That's what you're looking for. So there are 24 hours in one day, so you can cancel out your days, and now you're going to convert how much you're going to have per hour. See, it wasn't that bad. So you're going to have 26.5 milliliters per hour of fluids. That's how much your rate's going to be. Okay, now to question 7. Question 7 says a child is to receive IV fluids at maintenance rate. The child's weight is 28 pounds. So what are we going to do? Convert it to what? Kilograms. So 28 divided by 2.2. And you're going to use the rounding rules of rounding to 2 zeros, 2 decimal places. It says that at the top of the paper. That's why I keep saying your rounding rules. So you're going to do 12.73 kilograms. And it's 3 because the number after 2 is 7. The original weight is 12.727272 and beyond. So you're going to round that to 12.73 because the number after the 2 is above 5, so you round up. So we have our weight is 12.73 kilograms. Boom. First part of the question answered because it asks what is a child's weight in kilograms. Okay. So the next part of the question asks calculate the 24-hour fluid requirement for the patient. So according to our chart, if the patient is between 10 and 20 kilograms, the required daily fluid is 1,000 milliliters plus 50 milliliters per kilogram above 10 kilograms. I know this seems like a lot, but let's actually look at what we need to do. So we know our patient is 12.73 kilograms, right? So we're going to be within this range. So you're gonna automatically on top have 1,000 milliliters. Boom. You know that's the patient is going to receive 1,000 milliliters. But additional, they're going to receive 50 milliliters per kilogram above 10 kilograms. So what we're going to do from that is we're going to calculate this portion first, okay? Because that's the more complicated portion. So 50 milliliters per kilogram above 10. So we're going to do 10. Sorry. Because if we do that, it's going to be wrong. We're going to do 12.73 minus 10 is 2.73 kilograms above 10 kilograms. Okay? So you're going to do 50 milliliters per kilogram above 10 kilograms. So we have 2.73 kilograms above 10 kilograms. So we're going to do 50 milliliters per kilogram. So you're going to do 50 times 2.73, since that's how many kilograms you have above 10 kilograms. So you're going to have 136.5 milliliters additional of 1,000 milligrams. So you're going to have that additional to the 1,000 milliliters. Okay, so together, after that, we're just going to add 1,000 plus 136.5 because they're both milliliters. So essentially that's 1,136.5 milliliters of daily fluid. Okay, so now the next question is asking, let me highlight that in green. Oops, here we go with the lines. And this one, oh, we got that one in green too. Oops. So the next part is asking how many milliliters per hour are we needed to deliver the maintenance fluid. Okay, so here we go. What is it asking? It's asking for milliliters per hour, so don't freak out. So we have 1,136.5 milliliters per day, and in 1 day, just add our ones, there are 24 hours. So we're going to do the division there. So using our rounding rules, we get 47.35 milliliters per hour.